To our YouTube channel, and today we are going to see this problem Leetcode weekly contest 423, and the problem name is sum of good subsequences. This is the problem number 3rd. So what is given inside this problem? So we are given an integer array nums. A good subsequence is defined as the subsequence of nums where the absolute difference between any two consecutive elements in the subsequence is exactly 1. What does this mean? What is good sequence? 1 2, this is a good sequence, but 1 5, this is not. 1 6, this is not. 2 6, this is not. 5 6, yes, this is good. Okay, 1 2 are good, 5 6 are good because they have the difference of 1 only, right? And if we add 1 here, this is not a valid sequence. Why? Because the difference between two consecutive elements is not 1, it should be 1. Okay, so what is subsequence? Subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. We can't change the order. Okay, now we need to return the sum of all possible good sequences of nums, and definitely the answer will be large, so we need to return the modulo of 10 is 9 plus 7, right? And one more thing, that subsequence of size 1 is always considered good by definition. Like it is this, it will be good. 2 good, 3 good, 1 length all good, so not a problem. Now we will see example to understand it. Now in the first case we are given 1 2 1. So now we need to find what are the possibilities. So let's say we have this one here. Okay, this is a valid sequence, good sequence, right? Perfect. Now we need to make other sequence as well. So now we come here at this 2. Perfect. Now we are at this point. So is there any sequence available in which this can be add? We can add this. Is there anything? Yes, like there is a sequence already available here 1. If you do -1, this is already available. So what we can do, like 2 is the sequence and 1 2 is the sequence. Perfect. Now we are at this point 1. Okay, we are at this point 1. Is there a sequence already available that is ending at 0? No, there is no such sequence available. Is there a sequence available that ending at 2? Yes, these two are the sequence. So can we simply add them, add one more element and make a new sequence? Yep, that is possible. So let's add it. So 1 will be there, like that's a new sequence, right? Then we can have this 2 here, you can add 2 1, and in this 1 2 1 you can add 1. These are the possible sequences. Now let's calculate the sum. 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14, and this is your answer, right? So how can we calculate this? So we need to find the, like, one thing what we can do, like if we are starting generating all the possible sequences and then calculate the sum and then it is valid or not, we can do that. Obviously that's a straightforward approach and we can achieve that in O of n square. But O of n square is not allowed here because constants we are given as 10 raised 5. So if we do, it will be 10 raised 10. It is not allowed. Now we need to think something better. What is that better? If you see, like, how are we generating sequences? Sequence generation is like, if there is something, use it. If there is something, use it. And what we used? Did we use this? Did we use this? No. we only use the last number. We only use the last number. If we know that this sequence is end at this number, what we can add? How will you generate the sequence? Normally, let's say if you have 1, now you want to add a consecutive element. Either here you can add 0 or you can add 2, right? So you need only this information. Now let's say you have added 2. So what is the possibility? Now what you can add? Either you can add 1 or 3. These are the two possibilities only. So let's say you have added 3. Now what is the possibility? 4 or 2. So let's say we have added 4. So what is the dependency? Where is the dependency? Dependency is the last element. If somehow we can keep track of it, we are good. We can achieve our answer. Right? So let's do the dry run of this, then we'll see how can we approach. Okay. So 3, 4, 5. So 3, 4, 5, we don't have anything, just keep it 3. Perfect. Now we are coming to this point 4. We are coming to this point, and now I am trying to find, is there anything till now available which is ending at 3 and ending at 5. 5 we don't find anything, but 3 we have one thing. We have one thing. Okay. So let's 4 will be there obviously, because it can be a good sequence individually. And then we have 3, 4. Make sense? Now let's come to 5. Let's come to 5. Now we will try to find, is there anything that is available at 4? Yes, 4 we have. 4 we have. That means we can add 5, and then we have 4, 5, and then we can have 3, 4, 5. Do we have any kind of 6th thing? No, we don't have it. That means we can't build that, right? So if you add them up, this whole thing, it will be 40. And this is our answer. So what is the goal? Now we will keep track of how many times ending at this point happens, right? So let's try to build that. Let's try to build the solution. Now we are at 3. Okay. Now we are at 3. So what we need? We can search from 2 or we can search from 4. Is there anything available till now? No, nothing. So what we will do? We will update the frequency of this. The count of, let's say we have one count. So we have count of 3. That is 1. You can keep it. Or let's draw a table. Count of 3 is 1. Perfect. We got the count. Now we are coming to this point where 4. And we also need one more thing, sum. Sum we need. So what will be the sum? Let's say this is the sum array. At this point we will make one more table, that is sum. Now we are at this point. Do we have anything? No. So we are at 3. Okay. Sum of 3, like what is the frequency of it? Do we have anything? No. And what is the element? 3. So if we consider a sequence that is ending at 3, what is the sum? Sum is 3. And this one is the frequency. In the right side we have frequency, and here we have the sum ending at this point. Now we got this 4. Is there a thing available at 3? Yes, it is available. Is there a thing available at ending at 5? No, it's not available. So what will we add? We will add 4 to 1. 4 to 1. But this is 1. But this is the sequence that is ended at 3. We will add 1 to it. So 1 is already there. Now we can make one more new sequence, the number itself, whatever is available here, and we are able to make one more sequence. So it will be 2. Yes, makes sense. And now we need to sum, like we need to update our sum as well, right? So what is available? Like 3, we are at 4, so we want 3 and 5. 5 is not there, 3 is there, so 3 is the sum we have. Okay, and what is the sum? 3 is there, so we will add here. We will add here inside this. In 4, we will add that. One more sequence comes into the picture. Right? So this will be 3. Make sense? This will be 3. Now we want what we can add. This is 3. Till now it is 3. Now what we know? There is a sequence already available 1. The count of that is 1. Now we are adding one more element to it. So how many elements? We have added 2 elements. So we need to multiply this. 4. So what we need? We need 8. 4 times 2, 8. This is what we require. That is the earlier thing. Now we have added one more thing. Okay. So now we'll go further. Go till 5. Now we are at this point 5. Did we achieve anything? Is there anything possible till 5? 4, sorry. Yes, 4 we have. 2 sequences we have. Now how many sequences we can make? We can make 3 more sequences. So the frequency will be updated by 3. Perfect. Now we need to update this. The sum value. Sum will be what? We'll try to find the previous sum. Previous sum was 8 only. Previous sum for that is 8. So we got 8. Now that is added 5. This is we have 8. Alright. Now how will update the thing? Now the sequence will be updated like, okay, this will be updated. Sorry, this ending at 4 will be 11. Sorry, my bad. This is 11. How? We need to consider the previous as well. Like 4 to the 8 is contributing here and 3 is contributing earlier. So the value will be 11. Now what is the contribution of 5? So what was the earlier contribution? It was 11. Now what is the new contribution we are adding? Right? What is the new contribution we are adding? We are adding a 15. 15 we are adding. So 3, 4, 7, 3, 10, 14 and 15, 29, 29 and 4, 33 and 4, 37, 3, 40, right? Okay, so 11 plus this, what is this? This is 26. And how we got this? The contribution, like we found that it is a element ending at 4. So that is the contribution here. Now how many elements we can add? 3 elements only. 3. So 3 new sequences, like number of times the 5 will be added will be 3. So 5 into 3 will be 15. So it will be updated. So we are adding. So 11 plus 15, that will be 26. Now we are at the end. This is done, complete. Now we need to calculate the sum. So if you calculate the sum, 3, 11, 14, 26, that is 40. And this is our answer. Right? What happened? Like we are at 3, there is nothing. So we added that number only. Now we know there is a 3 available. When we came at this 4, there is 3 already available. Now we need to calculate the frequency of it. That is 1 already. Now we are making one more sequence of it. One more sequence, like we can make 2 sequence, one itself and one more. So the contribution will be the previous plus the current contribution. Current contribution will be the frequency. 2 into 4, that is 8. 8 plus 3 is 11. We have this. Now we are at 5. Now we want to find the contribution of 4. The contribution from 4 is 11. Now what is the new contribution? So for new contribution we need the frequency. What is the frequency available here? 2. We are adding one more element to it. What is the frequency? It will be upgraded to 3. So 3 times 5, that is 15. And we updated that value here. At the end we just need to take the sum, that is 40, and this is our answer. Okay, so let's see the code. How can we do that? So where is the code? Okay, wait a minute. Okay, so let's see the code here. No issues at all. So what we need? We need 2 maps, 2 unordered maps, count and sum, right? And what we do? We need to update our count, frequency. How can we update? We need to have the previous one and the next one. Like these are the numbers, plus 1, minus 1, plus 1, minus 1, right? So this is, it is not good to explain here. Let me, okay, yes. So what we need? Previous and next. Like if there is a number called 4, we want to find, is there 3, is there 5? That's why. And now we are adding one more, the current element. This is what we are adding. That's how we know how many sequences end at this point. Okay, and we need to calculate the mod. Mod is important because answer will be very large otherwise. Okay, we have calculated the mod, and the same thing we need for sum. Like find the sum of previous 3 and 5, whatever is available. So once we got that, we need to update. We also need to add new, that current value. What will be that? We need to multiply by I, the current element, and what is the frequency available? It is coming from these previous, whatever is the frequency that we got, we multiplied and added in our answer. At the end we need to calculate the sum, whatever is available here. In this we just need to take the sum. So we need to add the second value and take the modulus. That's it, and return at the end. What is the time complexity of this solution? As we have discussed in the starting, the time complexity is very straightforward. O of n, right? Why O of n? Because we are adding an element, like we are iterating all elements 1 and performing some computation. So for computation, is there any problem? No. Why there will be a problem? Is there any extra thing? You can say log n. No, no, no. Why? Because we are using unordered map. So the insertion time is O of 1. Right? We just need to calculate the hash and put it. And at the end we are taking the sum. So it is also in the worst case O of n. So, and what about space complexity? It is O of n. O of 2n we can say, but in real life we write like this, O of n. So this is the time complexity. This is the very straightforward solution for this problem. So I hope you understood this problem. If you understood this problem, do comment like you understood, you loved it. If you have any doubts, you can ask, and you can share this video, you can like this video, subscribe the channel. Keep coding, keep growing. Bye bye.